What if the entire universe could be described using just one constant? It sounds like the plot of a mind-bending sci-fi novel, but this is exactly what a recent paper suggests, and that constant is time. Yes, you read that right. Forget the dozens of fundamental constants physicists have relied on for centuries. Time alone might be the key to unlocking the secrets of the cosmos. But here's where it gets controversial. Does this mean all those other constants, like the speed of light or Planck's constant, are just convenient shortcuts? And this is the part most people miss. The idea isn't to discard these constants entirely, but to rethink how fundamentally necessary they are. Let's dive in. In 1992, over a cup of coffee at CERN, three physicists, Michael J. Duff, Lev B. Okun, and Gabriele Veneziano, found themselves in a heated debate. The question? How many constants are truly needed to describe the universe? Their disagreement sparked a series of papers in 2002, each proposing a different answer: 3 constants, 2 constants, or even 0. Okun argued for length, mass, and time, Veneziano for length and time, and Duff suggested it depended on the theoretical model. Fast forward to today, and a new paper led by George Matzes claims that time alone could be the ultimate constant, capable of measuring everything from space to mass. But how does this work? The team explored 2 types of spacetime: Galilean spacetime, where space and time are distinct, think Newtonian physics, and Minkowski spacetime, where they're deeply intertwined, thinks Einstein. In Galilean spacetime, you'd need both rulers and clocks to measure physical variables. But in relativistic spacetime, clocks alone might suffice. Why? Because in relativity, space and time are so interconnected that a single unit, time, can describe all quantities. High-precision atomic clocks, for instance, could theoretically replace rulers and other measurement tools. Here's where it gets even more fascinating. The team used a thought experiment proposed by physicist Bill Unruh to show how length can be derived from time in Minkowski spacetime. Imagine 2 observers at opposite ends of a rod, each with synchronized clocks. By measuring the time it takes for a clock to travel between them, you can calculate the rod's length, no rulers needed. This suggests that time isn't just a constant, it's the constant. But here's the controversial part. If time is all we need, why do we still use other constants like the speed of light or the kilogram? The answer lies in practicality. While time could theoretically replace these constants, they remain incredibly useful in everyday science and engineering. As Daniel Vanzella points out, the kilogram, defined during the French Revolution, is convenient but not fundamentally necessary. Mass, for example, can be derived from how particles accelerate in a gravitational field. So, does this mean we're on the brink of a scientific revolution? Not exactly. The other constants aren't going anywhere. They're too ingrained in our current systems. But this research challenges us to rethink what's truly fundamental in physics. And that's the beauty of science. It's always evolving, always questioning. What do you think? Is time the ultimate constant, or are we missing something? Let's debate in the comments. This is one conversation that's just getting started.